Hello students, today I am going to explain you what is meant by logic. Under that I am going to explain you the proportional logic. So here there are so many sections are there. So but today we are going to see the connectives and compound proportions. The next class we will see what is meant by tautology and contradiction, the problem related to that. And at last I am going to explain you the laws of logic and how to solve that problem. Okay, so let me start. So what is meant by logic? Logic is an analysis process of methods of reasoning. This analysis focuses on the form of reasoning and not the content in the reasoning. See, for example, all cats like fish. That is the truth. If Tom is a cat, so Tom likes fish. Okay, so related to the reasoning, so we are focusing on the form of reasoning and not the content in the reasoning. So we do not even have to know about the cat and the fish here. So we care whether the premises implies the conclusion. That's all. Here the premises is Tom is a cat. So we are get the conclusion that Tom likes fish. That's all. What the premise is, according to that we will get the conclusion. So we are not bothered about the content in the reasoning. So with logic one can distinguish between good and bad reasoning. Okay. This is the main definition of the logic. So for the logic we are analyzing the form of reasoning but not the content in the reasoning. So what is meant by proportion? So one aspect of mathematical logic is called the proportional logic. And another one is another type of logic which is not in our syllabus. So I am concentrate only the proportional logic. So fundamental objectives in proportional logic are so-called propositions. Here propositions cannot be both true and false. It cannot be both the one. It may be either true or false. So what's the definition of proposition? It's a statement which is either true or false. So true or false is called the, so you don't think that true only the truth value, false is also a truth value. So true or false is called the truth value of a proposition. Okay, keep it in mind. So this is the definition for the proposition. What are the example of proportion? The statement, Abu Dhabi is the capital of UAE. This is a true statement. Hence, so we are getting the truth value. Hence, it is a proportion. Next thing, 5 is greater than 7. This is a false statement. Even though it is a false statement, there is a truth value here. This is also a proportion. The next statement, every even number larger than 0 can be expressed as sum of two odd numbers. So every even number larger than 0 means, I will explain you this one through an example. So here what they have given, every even number. So every even, every even number larger than 0. For example, if you are considering a number 4, if you are considering a number 4 as an even number which is greater than 0, we can express a sum of two odd numbers. So 3 plus 1, which is 4. Okay, so this is a truth statement. I can express a 4 as 3 plus 1. So hence it is a proportion. The next thing, okay, I erase it. Please wait, I will come. What is meant by proportion? For convenience, it represents a proportion by a lowercase letter. We can represent the proportion. Here the given statement, the proportion Abu Dhabi is the capital of UAE, you can represent by the letter small p. So thus the proportion Abu Dhabi is the capital of UAE, we assign the letter p here. So another example, The statement, are you ready? Are you ready? We cannot get the confirmation whether you are ready or not. So I cannot get the confirmation whether it is true or false. So I don't have the truth value. So therefore it is not a proportion. Similarly, ready, steady, go. This is a command. So which has no truth value. So therefore here also a command is not a proportion. The next statement, x is greater than y. Here what is the value for x and y? I don't know. Because by using the value of x and y only, I can get the truth value. Here also I am not getting the truth value. So because we cannot assign until x and y are specified, so it is not a proportion. So in mathematics, such a statement is called predicate. That is the another type of logic, predicate logic, which is not in your syllabus. So we are going to see only the proportion logic. So please note that if you don't have that specify value for a variable, then we cannot have a truth value, then that statement is not a proportion. This represents predicate. Okay. Next thing, what are the connectives we are going to use for the proportion? More than one proportion can be connected using the proportional connectives to form a long compound statement or a logical expression. So each proportion has a truth value. At the end, we are interested in knowing the truth value of this compound statement or logical expression. Okay. By using the connectives, we can draw a truth table. By using the truth table also we can get the conclusion. I will explain you one by one. See, what are the connectives we are going to use for the proportional? There are 5 connectives: not, and, or, if then, and if and only if. So for each connective, the corresponding symbol and what is the type is given in the tabular column. So I will explain you one by one. Here the not is represented by the symbol negation symbol, that is, so instead of using this symbol, we can use the another symbol. So it depends upon the books, the author. They can use like this, or simply the negation symbol, negative symbol like this. So any symbol you can use it for the negation, and which is called conjunction, we need to use the inverted V, and for or, this is called disjunction, we need to use or symbol, that is the V symbol. For if then, we need to use the conditional, that is implies symbol, and if and only if, we need to use the biconditional, both the side the arrow. Okay, for if and only if. So we need to keep it in mind. Don't get confused with the and or. Okay, so any one we need to keep it in mind. Then the opposite to that we can to use it. Okay. The next thing, so we will see one by one the connectives. The first connective, the not connective. So not connective, which gives you the negation of a proportion. If you are using the not connective, that gives you that negates the proportion. Okay. If, for example, if P denotes the proportion, here the statement is today is Monday. If you are using the negation symbol for P, then your statement will come as today is not Monday. Okay, today is not Monday. The negation of the statement today is Monday is today is not Monday. The truth table for this connectivity is, if your proportion P represent the proportion and negation P, if a proportion is true, the negation P will be false. If your proportion is false, you will get the true statement. Okay. So this is mean by not connective. For example, if proportion represent Dubai is a city in UAE, so this is a true statement. So the negation for this statement is Dubai is not a city in UAE, but this is a false one, even though you are getting the truth value. So the negation, this is the false statement F. Okay, so according to the truth table, if it is true, you will get the negation statement as false. If your proportion is false statement, the negation will give you a truth statement. Another example, 8 is less than 5 is a false statement. If you are taking the negation, you will get 8 is not less than 5, which is a true statement. Okay. So that's all about the not connectivity. So you will have homework. Your proportion is given as final exam weights 40% of the total grade. Write down the negation P in words. Another homework problem. Given the statement a cube has 10 edges, what is the truth value of the statement? Write down the negation of the statement in words. So here the truth value, a cube has 10 edges. Please note it. The cube has 12 edges, no? So here it is false. The negation of the statement is the cube has not 10 edges, or a cube has 12 edges. Like that you can write. Okay. The next connectivity is unconnective. So unconnective means it conjuncts the two proportion. If you are taking P and Q be the two proportions, the conjunction of two proportions is represented as P and Q. Okay, for and statement you need to use the inverted V. So the conjunction is only true. This value will be true when it becomes true if both the value is true. This conjunction value will become true when both the value will be true. So see the truth table. If both the value is T, then only you will get the truth value for the conjunction. Otherwise you are getting the false value. Okay, for all possible true values of P and Q, the truth value of P and Q are shown in the table. Okay, we will have some example. Here, if you are having that P as Dubai is a city in UAE and Q as 8 less than 5, if you are making the conjunction like this is true statement, but this is a false statement. So your result will be the compound statement is false. And right, your compound statement is false. That is P and Q is false here. Conjunction of P and Q is same as Q and P. Here, if you are taking Q and P, 8 less than, here that is false, this is true. Even though you are interchanging the P and Q position, you will get the result as false. So the above compound statement is false. It will not affect, okay, for the AND statement. So homework for you. If you are taking P as a cube has 10 edges and cube has 8 corners, please write down the truth value for P and Q, Q and P, and also write in words. Okay, both the one. Please do take it as a homework problem. So the next thing, OR connective. There are two types of OR connectives. One is inclusive and exclusive. In the inclusive OR, the statement P or Q means P or Q or both. In the exclusive, we are considering P or Q does not mean both. Okay. The symbol we represent the inclusive OR and it is called disjunction. What is meant by AND? AND is the conjunction, but OR represent the disjunction. The disjunction of two proportions P and Q are represented by like this, P V Q. See, P V Q. So like that we will explain. So P or Q. So I will explain through a truth table. P or Q. So P or Q is false when it becomes false if any one of the value is false. Any one of the if both the P and Q is false, then P or Q will become false. So its value become false if both the one is false. See the truth table. If both the one is F, you will get the result as F. Otherwise, you will get truth value as true. So the truth value of P and Q for different all possible truth value is given in the table. So we will have an example. P, which represents Dubai is a city in UAE, and Q represent 8 is less than 5, the disjunction of the two proportion will give you. So here it is true, but here it is false. True or false will give you the truth statement. Here it is the true statement. Okay, that's the above compound statement is true, because we are saying Dubai is a city in UAE or 8 is less than 5. So here the or will comes as a true, because of Dubai is a city in UAE as a truth statement. Okay, for a homework, take this one as a homework. The next connectivity is if-then statement. So please take this one as a homework. I told you, everyone copied? Okay, I will go for if-then connective. The if-then connective is a conditional connective. Please note it. If-then connective is conditional connective. Wait a minute, I want to just make a small recap. What are the connectives we have seen so far? First one is the not connective, which gives you the negation. Second one is the unconnective, which gives you the conjunction of the two proportion. And third one is the or connective, which is the disjunction of the two proportion. Then the fourth one we are going to see now, the if-then connective. If-then connective is a conditional connective. Okay, if P then Q. If there is a statement of proportion, then you will get the conclusion as Q. So it is represented as P implies Q. We read it as P implies Q and call this connective as implication. Okay, implication. In a conditional statement, the proportion P is called antecedent and Q is called consequent. Okay, keep in mind these two words. So I am going to explain you the if-then connective through a truth table. So when the convention is that when the antecedent P is true, so your antecedent P is your antecedent and consequent is Q. If P is true and the consequent is false, then only your P implies Q is false. Otherwise, it is true. So all possible values summarized in the truth table. Please note it. When it will become false, if your consequent is true, when your antecedent is true and consequent is false, then you will have false. Otherwise, you will have true. So keep in mind only this part. Okay. So we will have one example. If P represent Dubai is a city in UAE and Q represent 8 is less than 5, the conditional if P then Q represent if Dubai is a city in UAE, then 8 less than 5. This is true. This is false. So what they have given the truth table, if true implies false, then you will have false. Okay. So here Dubai is a city in UAE, then 8 less than 5 will give you the false statement. Okay. Suppose if you are interchanging the P and Q, here the truth value will get changed. See, here it is false, here it is true, but you will have the true statement. See, even though it does not make any sense, but we need to consider, we should not consider the content of the statement, only the reasoning. Okay. Thus the above statement is true here, but before it is false. If you are interchanging P and Q, it will give the different result. Please note it in under the if-then connectivity. So this is the homework for you. So please finish it. Okay. Then the last connectivity is if and only if connective. So if and only if connective forms the biconditional of two proportion, and it is represented as biconditional means you are having the two arrows, no? That's why it is biconditional. That is, we need to read it as P if and only if Q. That is, the logical expression P if and only Q means here P implies Q and Q implies P, both the side. That's why it is called biconditional. Have both two conditionals are here. The pi conditional is always true when P and Q have the same truth value. For true implies if and only if true, you will get the truth value. Okay, if both are false also, you will have the truth value. See the truth table. So when you are getting the truth value, if both the one are same truth value. Same truth value means both. If it is true, you will get true. If both are false also, you will get the true. Okay, for P if and only if Q. So the biconditional P if and only Q is always true when P and Q have the same truth value. So we will have one example. If P represents Dubai is a city in UAE and Q represents 8 less than 5, the biconditional P if and only if Q is if Dubai is a city in UAE if and only if 8 less than 5. What you will get? What's the result you will get? Here Dubai is a city in UAE is a truth statement. Okay. It's a truth statement. Okay, this is the truth statement, but this is a false statement. So we are using if and only, both are different, so you will get the false statement. Okay, thus above compound statement is false. So take this one as a homework problem. So we are going to do the homework problem for if and only, just change it. Okay student, so far what are the things we have seen? So negation, today is not Monday. If you are taking today is Monday and Q it is raining, your negation P will comes as today is not Monday. Negation Q it comes as it is not raining. And P and Q means today is Monday and it is raining. Not P and Q means today is not Monday and. Okay, how to represent? So write the following logical expressions in words. So P or Q means today is Monday or it is raining. We need to include or. Here they have taken the negation, so it is not raining. We need to include. Here if today is Monday, then it is raining. So that is today is Monday implies it is raining. Also you can write it. They have taken the negation. If today is not Monday, then it is raining. It is here. If and only if today is Monday, if and only if it is raining. Today is not Monday, if and only if it is raining. Here today is Monday, if and only if it is not raining. Okay, hope that you can understand well all the connectivities. So the next example, from the next example onwards, I will explain you next class the compound proportions. So see here in this example, P represent my program runs and Q represent my program contains mistakes. So write the expression for P and not Q or Q. So this arise the compound statement. So for the compound statement, I will explain you in the next class. Okay, students, do you have any doubt? You can ask me. Shall I end up the meeting? Okay, see you. Bye bye.